with the base or vice versa. So in here I just have some water. This is a magnetic stirrer. Oh yeah, you got it. There's a little magnet bar in there that spins. Got a magnet underneath it. When I do demo shows, the kids love the magnetic stirrer more than anything else I do. So acid-base neutralizations can be really boring because the acid is usually a clear, colorless solution, and the base is usually a clear, colorless solution, and the salt makes a clear, colorless solution usually. So chemists can find out what's going on, and for me to keep my students from falling asleep, I use a substance called a universal indicator. Now, universal indicator, if you think red, orange, yellow, green, blue, indigo, violet. By the way, I don't think indigo is actually a color. I think they just needed a vowel in Roy G. Biv. Just saying. So, if you think of red on the acid end and violet is the base end, green in the middle is neutral, like water. So if it's on the red side, it's an acid, increasingly stronger. So on the violet side, it's base, increasingly stronger. This is pure water. What do you think it is? Green. Okay, but it's a mixture of complex organic compounds that changes color. What color we got?
Yellow.
I thought neutral water was supposed to be neutral.
Wow.
Actually, pure water is, but carbon dioxide reacts with water to make carbonic acid. Even just regular water is a little bit acid. Now, let's see what happens when we add a drop or two of 1 molar sodium hydroxide.
Whoa.
Now, I've got a base solution, sodium hydroxide. I'm going to neutralize it now with some hydrochloric acid. 1 molar hydrochloric acid. Same color?
No.
A little bit redder? I can make it even redder. Then I can neutralize the acid with the base. And then we neutralize the base with the acid. And the acid with the base. If I was able to titrate it and get it exactly back to neutral, what would be in the beaker? I did it! I can't believe it. So, at that instant, what was in the beaker? Hey, it's hard. I planned it that way. So, what was in the beaker? Water and salt. What salt? Say it. You got it? Sodium chloride, table salt. Remember, to a chemist, a salt is a product of any acid-base neutralization reaction. This is table salt, the salt that we use. Now, that was interesting, right?
Yeah.
No. That was boring. I mean, just, okay, I got some color change. But this is interesting. What if anybody can get sodium hydroxide out of a bottle? There's no fun in that. Let's make some sodium hydroxide.
No.
Yeah.
Are you putting water in there?
Water, yeah.
All right. So
You can tell, H2O. And this is sodium.
Is it sodium chloride?
No, it's just sodium metal. It's the element sodium. You ever seen it before? Zoom in. Whoa.
So you're going to put sodium metal in water?
Yeah.
All right. Is the sodium currently in oil? That was the question.
Yes, the sodium is currently in oil.
Because if sodium was stored out in Oregon,
It would be sodium hydroxide really quick. Because that's what we're going to make, is sodium hydroxide. Okay, so here's the sodium metal. Chunks of it, you see it in there. Keep it under oil so that it doesn't, because I got to keep it around and it's pretty active metal. So I'm going to get some of this out.
Here's just some cheese ratings.
So everybody can see.
Okay. It's pretty soft metal.
You gotta,
It's about the consistency of cheddar cheese. I can cut it with a butter knife.
you doing that now?
I'm about to. I want this a little bit further down. There you go. Now you can see it. Okay. Take a little bit of this. Dry off the mineral oil because I don't want a bunch of mineral oil around. I'm going to cut off a piece. And you can see, can you guys see it? And right where I cut it on the fresh cut side, it's shiny like a metal. There you can see it's metal. And I'm going to take a chunk of it. A little bit less. Put the rest of this back in here. Come back here.
You gonna put the lid on?
I will.
Can you get it away?
Yeah, I do. I put the lid on. And then we're going to drop it in the water and see what happens. Oh, but first, I almost forgot. You got to first put universal indicator in there. So is this, what color do you think the universal indicator is going to be? Talk to me, talk to me.
Yellow.
I hear people saying green because it's neutral. Some of you saying yellow because you know that carbon dioxide in the air dissolves in the water, makes carbonic acid, makes even regular water that's sitting around in the atmosphere a little bit yellow, slightly acidic. If you drink a glass of water, it's a little bit acidic from carbon dioxide in the air, reacting to form carbonic acid. A little bit. Okay, so we see it's a little bit on the yellow side, close to green. Then we're going to add our sodium to it. It immediately melts. It's moving around on a little film of hydrogen gas because it reacts with the water to make sodium hydroxide and hydrogen gas. It's a single displacement reaction.
So you're saying if we made NaOH, and we know that's aqueous, and H2 gas, we're going to keep that together as a molecule, but it's not balanced. How do you balance this? We have 3 hydrogens here and only 2 hydrogens there. What do we need to do? Now we're going to put a 2 in front of the sodium. Now I've got 2 sodiums there. I'm going to put 2 sodiums there. Now I have 4 hydrogens, 2 oxygens. What do I need to do in front of the water? 2 here. All right.
Okay, so I could neutralize this with my hydrochloric acid. I've got a base, I've got an acid, I can neutralize it. But that would be boring. So what I want to do, I said carbon dioxide reacts with water to make carbonic acid. Have you talked about strong and weak acids yet?
They should know that there are 6 strong acids in life.
Was carbonic acid one of them?
No.
No, so it's a
Weak acid.
okay, so we got strong base, weak acid. Because carbon dioxide reacts with water to make carbonic acid. You've all drunk carbonic acid in your carbonated beverages. Soda pop. You drank it, that's what makes it taste tangy and makes it bubbly. This is dry ice. We're going to have some solid carbon dioxide.
That's
Carbon
CO2.
dioxide. CO2. Now carbon dioxide, that's at negative 95 degrees Celsius. Carbon dioxide is, does not, the reason it's called dry ice is that it doesn't melt. It's subliming. When it gets warmer, it comes off as a gas, not as a liquid. So if I left that there, I wouldn't have a puddle of liquid carbon dioxide.
So you're going to put CO2 solid
Yes.
in H2O liquid.
Yes. But it's really the gas that's reacting because it'll make gas immediately.
Here we go.
Okay, ready? And so it's going to form carbonic acid. Carbonic acid is going to neutralize the sodium hydroxide, changing the purple into red, or that direction anyway. So has it changed yet?
No. Add some more.
How about now? More? Do more. it changed yet? So it's making it, stirring it, and stirring in this carbon dioxide, making carbonic acid. Is it changing? Yeah.
There we go.
There we go. And it turns out that's as far as it goes, because carbonic acid is a weak acid, because it's not on our list of strong acids. It's a weak acid, so it won't take it all the way to red. Which is a good thing. It's not a strong acid, because we drink it in soda pop. We wouldn't want to be drinking a strong acid. Okay, so another acid-base neutralization reaction. There you have it.